I'm going to make another video here for our Engineering Excel class. And I want to talk about money. And in particular, if we deposit money in a bank, depending on the interest rate and how the interest rate is calculated, how our money deposit or bank deposit gains value. I'm also going to talk about loan amortization. That is when we borrow money from a bank and then we make monthly payments. What should be the size of each monthly payment and how do we calculate it and how long will it take to pay back the loan? Okay, so first I want to talk about bank deposits. And I have this spreadsheet already made up. So if you go along with me here, I'm going to say that I'm going to deposit $10,000. You see right here, $10,000 in the bank. And I'm going to say that money earns 2% a year. And it's compounded once a year. What that means is that after the first year, we take 2% of $10,000, which is $200, add that amount to the original 10,000, so we now have 10,200. Now, in the second year, we take this as our new principal. So we start off with $10,000. After 1 year, we compute the amount A. I have it in this formula right here. We compute the amount A. We take our $10,000 P, multiply by 1 plus 0.02, our interest that we earn, and that gives us our new amount, $10,200. Now that new amount here, $10,200, is our principal for the second year. That also earns 2% interest. So after the second year, the amount that we would have is taking this amount A and then multiplying that by 1 plus 0.02. So the second year, we have that amount. For the third year, we computed by just putting in another factor of 1.02 out here, 1 plus 0.02, and multiplying that. So as we go down, each year we take 2% of the amount before, add it, that's our new principal. So we take 2% of this, add it to that, this is our new principal. 2% of this, add it to that, this is our principal, and so on. So after 20 years, with an original deposit of $10,000, we now have $14,859.47 in the bank. Okay, not a whole lot of interest earned there. Now suppose that the amount is, instead of being added, the interest, instead of being added at the end of the year, we add the interest every quarter. But here's what we're going to do. We start off with $10,000. Now, instead of adding, after 3 months, instead of adding 2%, we take 2% and divide it by 4. Why? Because a quarter of a year means that over that 3-month period, we wouldn't have earned the full 2%. We would have earned a quarter of that 2%. Now our new principal is, at the end of the first 3 months, is this amount times A. So we have 1, let me write that equation right here. We have 1 plus O2 divided by 4 there. Then we have times 1 plus O2 divided by 4. So after the first 3 months, we have this much in the bank now because they added a fourth of our interest. After the second 3 months, this is our new principal, and they add another fourth of the interest. And they do that 4 times for the whole year. So after the first year, what we have is our principal times 1 plus 0.02 divided by 4 raised to the 4th power, because n equal 1, meaning the first year. So it's this raised to the fourth power. So the number computed here, let me just delete that. This now is the amount of money we have at the end of the first year if our interest is compounded quarterly. In other words, we get credit for the money we were earned after 3 months, and we don't have to wait for the whole year. But of course, after 3 months, we've only earned a fourth of the interest we would have gotten over the whole year. So this is what we get at the end of the year, $10,201.51 versus $10,200, a little bit more. And then when you go down here and you see after 20 years, we have $14,903.39. Whoopee. Not that much difference, is it? Now we could compound our interest monthly, in which we would take P times 1.02 divided by 12 raised to the 12n power, where n is the year number. So for year 1, we would have 1 plus 0.02 divided by 12, all raised to the 12th power. So the formula we have would be compounded quarterly, compounded monthly, would be just like this. Let me write it out. It would be A, the amount that we have after n years, equals P times 1 plus 0.02 divided by 12 raised to the 12n power, where n is the number of years. So n equal 1, we have the amount after the first year. N equal 2, we have the amount after the second year. So if it's compounded monthly, this is the amount that we end up after 12 years. Compounding periods after 20 years with a compounding period once a month, we end up with $14,913.28. Now compare that to these two numbers, 14,859, 14,903. It's getting a little bit better, okay? Not too bad. Now, if we go to what's called continuous compounding, that means for every instant of time, the little bit of interest we earn is added to our principal amount. And if we do that, what we do is we take a formula like this, and instead of dividing by 12 or raising the 12n power, if we compounded it every day, we say you have 365 days in the year. This would be 365, and this would be raised to the 365n power. So here we have to use a little bit of math. We have to say whatever this is. Now, if we compound it at every infinitesimal period, okay, we raise this limit as this number goes to infinity and this number goes to infinity. So if we do that limiting operation, which I'm not going to do because it's something you would have done. You would have either looked at it in your algebra class, or you may have actually computed it in a calculus class. But this is the formula for continuous compounding. The amount that we have is equal to your principal times the exponent. That's e raised to the RT power, okay? Where t is the time and r is the interest rate. In this case, our interest rate is 2%. So we do P, 10,000, times E to the RT. T is the time, 20 years. So let's try that calculation and see what we get. Do we get 14,918.25? So I pull out my RPN calculator and I say, okay, R is 2%. So we have 0.02, enter. T is 20 years. 20 times, okay, and then we want to raise that to the e power. That's this function. And then I want to multiply by $10,000 and I get indeed $14,918 right there. Okay, so um, this is the formula that we get doing a limiting operation on our compounded annually, compounded quarterly, compounded monthly, and so on. Okay, it was first done by the Swiss mathematician Leonhard Euler. Okay, now, so much. I know you probably have talked about this type of calculation. Okay, now how do I get rid of this thing here? Who knows? I don't need to get rid of it right now. Okay, now I want to talk about loan amortization. So let's say we borrow $10,000, and then we're going to pay that $10,000 loan back over a 20-year period. Now, then the question is, we want to make the same payment every month for 20 years. What should that payment be? And if we decide partway through the loan that we're going to pay it all back, how do we calculate how much money we still owe? And Excel has a built-in function for doing that. It's called the PMT function. And but first, as I'm going to pull up PMT and talk about what are the arguments inside here, say what it is that we're doing here. So I've already calculated $10,000 loan, interest rate of 2%, 240 months, that's 20 years. Calculated that our monthly payment will be $50.59. So out of that $50.59, now what we have to do is figure out after 1 month how much interest we owe the bank. So we're going to pay, we're going to borrow the money. 1 month later, we make our first loan payment. We're going to pay $50.59. And what happens then is that $50.59 has to pay off entirely the added interest. We're paying the bank interest now. They're not paying us. So we have to figure out how much interest has been added to the amount we borrowed. In this case, it's $16.67. So we have to pay that out. Plus, we have to pay out a certain amount of the original $10,000 we borrowed, or we're not paying off the loan. So the principal gets reduced by $33.92, and we also are then paying $16.67 because they gave us the loan. This is called the cost of money here. So we borrow that, we pay them back, profit to the bank, plus a certain amount on our loan. So how do we come up with this? Well, we use the PMT function in Excel. So how does that work here? Let me find the PMT function here. Now go auto sum, more functions. So here we are. Now I want to go to PMT here, go down here, go down here. We'll get there eventually. We're in the P's in PMT right here. And for some reason, it doesn't like it the first time I click on it. Who knows? Strange Microsoft things. There we go, PMT. So this tells us PMT function here. So PMT, the first number is the rate, okay? And this is not the rate per year, but the rate per month. So the rate per month is the rate per year divided by 12. So we would take 0.02 and divide by 12. So that should be that first number here. Let's look here where I made the calculation. No, I can't. It's not letting me click on it now. There we go. Okay. Right here is my... Okay, PMT is in here. Okay, B35, 2%. So I take what's in cell B35, divide by 12. That's what that says right there. So I take 2%, divide by 12. The second number in the PMT, I've lost that here again. More functions, which wouldn't be giving me so many problems. Show all functions. Yeah, search. Let me just type PMT. PMT. There we go. So this is our 2% divided by 12. N per is the total number of payments for the loan. Well, we're paying monthly. That's 12 payments a year. We're paying for 20 years. That's 240 payments. PV is the present value, the total amount that a series of future payments is worth now. Okay, well, what is that? This is, this is accountant speak. I'll tell you in a minute. FV is the future value, and type is a logical value that determines whether we're making our payment in the beginning of the month or at the end of the month. Put it equal 1 is at the end of the month. Okay, now PV is the present value. So let's look. PV is the third number here in PMT, the third number. So let's see what it looks like up here. Here's PMT. So first number, interest divided by 12. Second number, B36, is the number of months. Then we say we take B34. B34. Our total loan amount is $10,000. And when they talk about present value, that's what we're borrowing, $10,000. Okay, and then I have 0 here. So that is the type, the logical value. Okay, so payment at the end of the period is 0. Payment at the beginning period is 1. Payment at the beginning of period, to me, kind of doesn't make much sense because it's saying you borrow $10,000 and then you turn around and pay them immediately the first payment out of that $10,000. Payment at the end of the period is you borrow $10,000 and you make your first payment a month later. So I'm putting in payment at the end of the period, which is 0. Notice I have a 0 right here. Now, notice that I have my PMT function here is inside the round function, because when I make my payment to the bank, I'm not making payments of a fraction of a cent. So I'm taking my payment and rounding it to 2 decimal places. Okay? So that then calculates what the payment should be every month that I'm making payments on the loan. So these letters here aren't they're just example letters. The real letters, the real cells are the ones that are up here, just to let you know that. Okay, now, so that's how we calculate how much we have to pay. Now notice what we have here. So at the end of the first month, at the beginning of the second month, let's say, we pay $50.59. Okay, this much goes to comes off our $10,000. This much the bank keeps as their profit. After the second month, we pay again $50.59. This much comes off of our original $10,000, which has now been reduced by this month, by the way, because the $10,000 minus this amount is now the new amount of our loan. So we pay off $50.59. We're now paying off a little bit more on the principal. Bank gets a little less. Third payment, fourth payment. So you see, as we go on, the total amount of money that gets deducted from our principal gradually increases, and the total amount of money that we pay in interest gradually decreases. And every month we have to pay off the interest for that month and then a little bit of the original loan. So right here, what I have in this column is the cumulative principal. Okay, and as we're making payments on our principal, first month we pay this month, then we add this amount, then we add this amount to it, and then we add this amount to it. So this is how much we have actually paid off on our loan at any pay period, and then we have our the total interest we've earned. So what's really interesting here is you go down and you see in the beginning you're actually paying off very little of your loan amount. Most of that, a good fraction, maybe not most of it, is going to give the bank their profit, the interest that the bank earns on the money they loan you. And as we go along here, what you see is the money that the bank earns goes down and the principal you're paying off on the loan goes up. So you keep taking this and you see you're paying off more and more of the loan. That goes down here, and then at the end of our 240, we go down to 240 down here is our last payment. So we're getting down to the end. See what's happening here is that most of our $50 is now going to paying off the principal, with a very small going to pay off interest. And then at the very end, okay, here I've got, looks like 242 payments, is what I calculated. At the very end, we should have, oh, there we go, keep going down here. We have our last payment, this much going to the, oh, this isn't the end yet. This much going to our paying off our principal, this much going to the bank and profit. Now, keep going down here, keep going down here. Okay, down here, 240. This was payment 240, not this. 240. Our final payment here, 5059. We have almost the entire amount's going up to paying off principal. Only a little bit's going to pay off interest. We have now paid off our entire loan, actually here 50 cents more, so we might want to reduce this last payment by 49 cents to make 50.10 here instead of 50.59. And then this is how much money the bank has earned on loaning you that. And so the total amount that you've paid back on the loan would be the sum of this plus that. But like I said, your last payment may not actually be 50.59 because you don't want to pay back more than $10,000. So the loan amortization calculation is a little bit more complicated. And actually, what I have found is you can go online and you have websites that do loan amortization calculation. And what I have found is those websites don't always give you exactly the same numbers from one to the other. And they also don't always completely match up with this, although they're usually very, very close. So it'd be interesting to investigate down the road what some of these differences are. And my guess is some of the differences might be when you make that first payment, for example, we go back up here, we make our first payment. Do they count that first payment? Suppose we make the first payment at the end of the first month. Do they count that as making the payment at the beginning of the loan, at the beginning of the first month, or do they count that as making a payment? Do they count that as a payment at the beginning of the second month, which is when your payback starts, or do they count that as a payment which is at the end of the first month? You understand the subtlety of the difference here? So, yes, paying interest back on a loan, like is shown here, is a little bit more complicated. And even though in the beginning of the loan you're still paying off the same amount every month, you actually make a very small dent in the principal that you owe the bank, because a good fraction of your payment amount is going to interest. Now, with some credit cards, used to be in the past, maybe still is true, I try to pay off my entire credit card bill every month to avoid accumulating interest on the loan. But credit cards will give you very small monthly payments. The minimum payment is just enough to pay off the interest you owe on the amount, and with a very little of your monthly payment going to paying off the principal. So with credit cards, they have historically designed your minimum payment so that you're actually paying off very little of the credit card amount every month, and it really socks it to you, is that you keep borrowing up to your credit limit, then you make the minimum payments, and it can take you forever to pay off that loan because most of your monthly payment is going to interest. Okay, so that's all I'm going to say right now for depositing money and earning interest, and borrowing money and paying interest. So until my next video.